Alright, so x minus a squared plus y minus k squared equals 1. That's the equation for a circle. Okay? Well, it's kind of, if the equation for a circle is written something like this, this is still in a circle, but you can't really tell where the center is, you can't really tell what the radius is. So your goal is to make it look like this. Alright? So in order to make it look like this, you need to come up with these perfect squares, these quantity squareds that are on this side of the equal sign, so it's easier to tell where the center is and what the radius is. That process is called completing the square, or making something become a perfect square. What do I mean by something that's a perfect square? Well, this is a perfect square right here. Okay? This is a perfect square because if I were to factor this, what times what gives me x squared? X times x. And what two numbers multiply to 25 and add to negative 10? Negative 5 and negative 5. So x minus 5 times x minus 5 is the same thing as x minus 5 squared. Okay? So this is a perfect square. This can be rewritten as x minus 5 quantity squared. What questions do you have on that? Do you recall that from Algebra 1? We're okay there? Okay? Some of you know. Ask me then, please. Okay? So, if I want to create a perfect square, I need those three terms so that I can factor it. Alright? So I need x squared plus 8x plus something, and I need y squared minus 4x plus something. Okay? Well, how do we figure out what that something is that would make it become a perfect square? Well, the trick is you just take the linear term, if there is one. Okay, take the linear term, take the coefficient on that linear term, cut it in half. So what's half of 8? 4. What's 4 squared then? 16. Okay, so you take half of the linear term, cut it in half, and then square it, and that's the number that goes in the blank. Okay, because by doing that, I have created a perfect square. This is a perfect square, because if I were to factor it, what times what gives me x squared? X times x. And what two numbers multiply to 16 and add to 8? 4 and 4, right? So x plus 4, which would be x plus 4 quantity squared. So I have taken this and created this, which is awesome, because if I can create perfect squares, it's starting to look more like a circle formula. Okay? Same thing with the y's here, alright? Same thing with the y's. In order to make this a perfect square, I just take this value, I cut it in half, and then I square it. What do I get? 4. Okay? Then if I were to factor that, what times what gives me y squared? Y times y. And what two numbers multiply to positive 4 and add to negative 4?
Negative 2.
Negative 2 and negative 2. Okay? Because negative 2 times negative 2 gives me a positive 4, negative 2 plus negative 2 gives me a negative 4. So really what I have here is y minus 2 quantity squared. Now the key is though, I've added this 16 here. Well, in order to keep the equal sign true, if I add 16 to the left side of the equal sign, I better add 16 to the right side of the equal sign. And if I add 4 to the left side, I better add 4 over there too. Alright, so now I have x plus 4 squared plus y minus 2 squared equals, what's that, 32? Okay? So now it's easy to see my center is where? Negative 4, 2. And my radius would be the square root of 32, which would reduce to 4 root 2 if you did simplest radical form. What questions do you have? Nothing? Okay. What if it is? What if something already is a perfect square? Well, then that makes life easy. Alright? For instance, something like this. Okay? This one's nice already. Okay, this one's easy. X squared, oops, let's make that a y. X squared is just like x minus 0 squared, right?
Yes.
Okay? And this other one, isn't that already a perfect square? What would that factor to?
Y and 3.
Y plus 3 and y plus 3. So really I have x minus 0 squared plus y plus 3 squared. And I didn't have to do anything to it. That one was already a perfect square. I just had to recognize it. Okay? So there's another example. The center would be at 0, negative 3, and my radius would be 5.